Welcome to Moo Math. Today we're going to look at some rules with exponents and rational exponents. Okay, the first one is rule 1, multiplying with like bases. So if you have two bases that are alike, so we have x's that are our bases, and we have the exponents, 5 and 7 that are in the square root. So we have the square root of x to the 5th times the square root of x to the 7th. Okay, what I'm going to do first is I'm going to rewrite these as rational exponents, so fractions. I'm going to write this as x to the 5 halves, and where that 2 comes from is here. There's a square root there, which we assume we know that's a square root, times x to the, and in this case there's a 2 there that we assume, and we write it as 7 halves. So the powers on the top in the numerator, and the square, the cube root, whatever root it is in the denominator. Now once I get it written like this, it's very easy. Now I just add my exponents. So when you have like bases, add exponents. So I'm going to give x to the 5 halves plus 7 halves gives me 12 halves. So just add the top, the numerator, and that simplifies to x to the 6th, and that is the final answer. Okay, let's look at a second one. Okay, this one's already written with our fractional exponents. So we have x to the 1/2, which is the same thing as a square root, y to the 1/3, which is a cube root, all times the next term, which is x to the 2/3, y to the 1/2. Okay, I'm going to group my variables together. So I'm going to take x to the 1/2, and I'm going to multiply it times this x to the 2/3. So remember, I'm going to add my exponents. So I'm just going to write a little addition problem in the exponents. And then y to the 1/3 plus 1/2. Now notice I have different denominators. So I'm going to have to get a common denominator. So this is going to give me x to the 3/6, because 6 is my denominator. And then plus 4/6. So the final answer for x is going to be x to the 7/6. Okay, and then the y's, I got a 1/3 and a 1/2, and I need to add those two exponents. And again, my denominator should be 6, so I'll get 2/6 for the 1/3 plus 3/6. That's going to add to 5/6. So y to the 5/6. Okay, so I can leave it with rational exponents, or I can also switch it back to radical form. Since the denominator is the same, I can now do the 6th root of x to the 7th, y to the 5th. And that would be my final answer. Okay? So now let's look at the rules for dividing. Okay, the dividing is very similar to the multiplying rule. When we divide with like bases, we're going to subtract the exponents. So the first thing I want to do is take my rational and rewrite it as a fractional exponent instead of a radical. So I've got the square root of a to the 5th, so that's 5 halves all over a to the, in this case that's squared inside cubed on the outside, so that's 2/3. Now I need to subtract my exponents because I'm dividing with like bases. So 5 halves minus 2/3. Now I've got to get a common denominator so I can subtract. So that's going to be a to the, let's multiply everything here by 3, 15/6, minus, multiply everything here by 2, 4/6. And that leaves me with a to the 11/6. And you can leave it like that. Or if you need to write it as a radical, remember this is your root. So I have the 6th root of a to the 11th, and that actually simplifies to, I'm going to have to go backwards here, sorry about that. You're going to bring an a on the outside because you have more than 6 a's on the inside, 6th root a to the 5th, because that's how many would be left once you rationalize and find 6 pairs of 6.